Hi. So in this session we'll discuss design of piercing and blanking punches. We'll discuss different types of punches, plain punches, then pedestal punches, then punch shaders, knockouts, pilots. So we'll discuss the strippers. In this lecture we'll discuss all these things, the theory behind the working principle and construction features we'll discuss in this lecture. So the punch must withstand the maximum blanking or piercing pressure. They should not deflect during operation. Deflection of punches may be avoided by making the body diameter of punch larger than cutting diameter. Small punches may require punch support to prevent breakage. So this is very important while designing of punch. So it must withstand maximum blanking or piercing pressure. It should not deflect during the operation. So deflection of punches may be avoided by making the body diameter of punch larger than cutting diameter. So that it can absorb shocks and it will avoid deflection. Punch plates serve to hold position and strengthen the punch. Piercing punches should not be smaller in diameter than the thickness of stock they are to pierce. This is also important. Always avoid designing punches that would have more than 4 inches of unguided length. So these are some guidelines we have to follow during punch design. Punch plate serve to hold the position and strengthen the punch. Piercing punches should not be smaller in diameter than the thickness of stock. Means piercing punch diameter should be greater than the thickness of stock. So always avoid designing punches that would have more than 4 inches of unguided length. So the maximum length that can be extended, which is unguided, is only 4 inch. So it should have less length than that of 4 inch, which is unguided. So let us see, these are some punches. These are plain punches. So this is punch. So punch is fitted with a punch plate, and punch plate is held by this punch holder. Then it is connected with ram if it is a conventional type of punch. This is a die. And this is a workpiece. So see, the punch body, the diameter of punch body is more than actual cutting body of this punch to avoid deflection. So these are different shapes of punches you can see in the diagram. So let us discuss the first type of punch, that is plain punches. They are simply a block of hardened tool steel shaped to confirm the cutting contour. Screws and dowels secure plain punches. Plain punches must be large enough in the area to allow for screws and dowels. Screw and dowel holes should be located at least 1.5 to 2 times the screw or dowel diameter from the cutting edge. So these are some important parameters we should consider in plain punches. So plain punches must be large enough in area to allow for screws and dowels. Screw and dowel holes should be located at least 1.5 to 2 times the screw or dowel diameter from the cutting edge. Why this care should be taken while designing of this punch? As the huge force is applied during the punching or piercing or blanking operation, That's why this care should be taken. So in punches, see if this is a punch, okay, then there should be distance, sufficient enough distance. It should be 1.5 to 2 times of this diameter. So this is about plain punches, plain punch, and dowels are there. It should be large enough to fit this dowel and screws, which holds this punch with the punch holder. Then let us see next type of punch, that is a pedestal punch. Pedestal punches construction. So this pedestal punch is constructed by machining in such a manner that leaves a flange around the base of the punch. This punch always has a base area larger than its cutting face area. Its major advantage is stability caused by the large base and solid construction. Cutting forces are dispersed through the large area, large base, so used for heavy cutting loads. This is suitable for heavy cutting load. You can see in the diagram, so base is large than its cutting edge. So these are suitable for heavy cutting loads. So major advantage is the stability caused by large base and solid construction. Large base and solid construction. So it is fitted to the punch plate at this particular area, and this punch is free to bear a load as it is having large area base. Then punch shaders in piercing and blanking. Sometimes slug or blank clings to the punch face called slug pulling. Another factor of slug pulling is lubricant. Heavy lubricants make slugs cling to punch face. Slug pulling caused by heavy lubricants can be reduced by using lower viscosity lubricant. Another method is use shaders. So shaders are used. So first method is to use lower viscosity lubricant, and another method is to use shaders. Shaders are used to remove the slug pullings. Spring actuated shader, the pin is there, shader pin, are located in the center of the punch. Air pressure may also be used to prevent slug pulling. This method is more complicated and also tends to blow lubricant away from the cutting areas. So air pressure is not usually preferred. Instead of that, the spring actuated shader pins are used, which is located at the center of the punch. So you can see, so these are shaders, punch shaders are used. Sometimes air pressure is used, sometimes punch shaders are used. Punch shaders are used to remove the plug cocking. So these are used to remove the slug pulling. Now, so how to find out maximum allowable punch length? So you know that the length should not be more than 4 inch without uncovered, okay, the free length. So let us see the formula. LM, if it is a length of punch, equal to pi d by 8 into E is a Young's modulus, D into Fs shear stress, and this is a material thickness. So this formula is used. L equal to pi d by 8 Ed divided by Fst. It is under root. under root ED by FST, where D by T equal to 1.1 or higher. D by T ratio should be 1.1 or higher, means diameter should be at least greater than thickness, by 10% greater than thickness, at least 10% larger diameter. So this is very important. While punch designing, the punch diameter should be greater than material thickness. So at least 10% greater than material thickness. Then we'll see the knockouts. In normal operations, the slug clings to the die wall because of spring back in the blank or slug. Knockouts are used to remove workpiece that adhere to the die opening. The upper end of knockout registers against the knockout bar of the press, which pushes the shader down so that the workpiece is pushed back. So knockouts are used to separate out workpiece. Knockouts are used to remove workpiece that adhere to the die opening. So these are knockout bars are used to remove workpiece which is adhered to die. See here, this is how the workpiece is removed after punching takes place or after any press operation completed. Then pilots are used. The function of pilot is to position the workpiece or stock strip accurately. In progressive dies, to locate the work strip so that the relationship between stations may be maintained. So the advantage is taken of these holes so that the blank formed is exactly concentric to the pierced hole. So this piloting is obtained with the help of pilots secured to the blanking punches. So pilots are fitted to the punches by different methods. Different methods are press fit pilot, threaded shank pilots, socket set screw pilots. If the operation is slow, the pilots may be press fitted into hole in the center of punch. If there is any danger of pilot dropping out, it should be fastened. So let us see different types of pilots. So this is punch. So it is a punch holder. So it is used in combination with different parts. So it is why it is used? It is used to locate, to position the workpiece or stock strip accurately. This is a major function of pilot. In progressive die, it helps. These are different types of pilots. Let us discuss strippers. Strippers are used to remove the stock from the punch after a blanking or piercing operation. The strippers are classified as fixed strippers and spring operated strippers. Fixed strippers are solidly attached to the die block or die shoe. Spring operated strippers travel up and down on the shank of the punch. In last few diagrams we seen the strippers. So channel strippers, a type of fixed stripper which consists of a rectangular plate mounted on the top of die block. A channel or groove is milled through which the strip is passed. The height of the channel should be 1.5 times the stock thickness. The width must be equal to the strip width plus some clearance to allow variation in strip width. So this is called the channel stripper. So this is a channel stripper. You can see in a diagram. Then spring operated strippers. These are also called pressure pad strippers. Employ springs to apply pressure to the stock strip, suspended from the punch holder with stripper bolts and compression springs. The advantage of this type of stripper is that it tends to hold the strip flat during the press cycle. It also helps in holding the strip, supporting the strip, and later on it helps to remove the blank. So this is the example you can see in a figure. Spring operated strippers. These are strippers and spring operated strippers. These are also acting as a pad or supporting part on the blank. Then next we'll discuss die stops. These are also called as stock stops. These stock stops used to locate the stock in the die set when hand feeding. The simplest form of stock stop is dowel pin. An edge of previously blanked opening is pushed against this pin. The stock is lifted above the pin on return stroke to release the strip from pin. Demands considerable skill on the part of operator. So this is used in hand feeding. So die stops or stock stops. So these are used to locate the stock, means workpiece, in the die set when hand feeding is there. If automation is there, there is a stopper, it automatically recognizes, and pilots are used there. The simplest form of stock stop is dowel pin. The edge of previously blanked opening is pushed against this pin. The stock is lifted above the pin on return stroke and release the strip from pin. So it requires considerable skill on the part of operator. Operator skills are required here. So it is a stripper is there, punch is there, and sheet is there, sheet metal is there. So it is located. See here, it is a called stop pin. So stop pins are used to hold or locate the sheet properly. So this is generally used in manual operations. Okay, this is about the stock stops. So trip stop is another type of stock stop. The pawl rises on ratchet principle. When the operator pulls the stock back, the pawl drops and locates the stock. A ratchet is a device used to restrict motion in one direction. So here in this diagram you can see this ratchet, stock stops. You can see it is used to position your workpiece and stops this workpiece. You can see this is ratchet. Finger stops are there. Finger stops are used to start new strips in the proper location in a die. They are pushed into the stock channel until they sit. The press is stripped, the stop is released and returns to its out position. It is not used again until new strip is started. They are also called as primary stops. So finger stops are used to start new strips in the proper location in a die. These finger stops are pushed into the stock channel until they sit. The press is stripped. the stop is released and returns to its out position. It is not used again until a new strip is started. These are also called as primary stops. So let us see, this is a finger stop. This is a finger stop is used at an initial stage. It is used. Now later on the different other type of finger stops are used. Thank you. Thank you very much. If any doubt, you can ask your query. You can ask your query in chat box. Also, you can personally ask your queries. Thank you. Thank you very much.